Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch in Go, where we using this book called Neural Networks from Scratch in Python, but we write in everything with a Golang. And right now we're going to the next chapter, not this one, where is it? It's called Model Object. And the whole idea, I think, of this chapter is to actually create a class that will represent a model. And I will keep an eye on what are the changes here. I mean, I will keep an eye on what are the changes here in the Python code, but I will need to do things a little bit different because of the Golang. And yeah, and I will do this. And I think the next couple of the videos will be more um, like pure coding because I have this to-do list that I need to do in order to move forward. For example, I have these two fixes uh, because, for example, right now the what is it? For example, the mean absolute error, mean square error, and the binary cross entropy loss is built specifically for the examples that we have, and they won't support models with multiple outputs. Same applies for loss function that takes the wind slice and the float 64 slice as the target values. And I will need to change it into the dense class so I can make them generic, and all of the data that I will have, I mean the target data that we'll have will be represented as the dense class. So we can do something like we can we won't be dependent on the model type, well, on the data type. So it will always be the same. It will have rows and the columns, so we can combine it in different ways. And plus, I need to do these three things: create an interface for the layer and activation, create an interface for the loss and for the optimizers. And the reason for this is actually, you can see here. So right now, I cannot do something like this because the dense layer and the activations is totally different. Well, not classes, but structs in my case. And the proper way will be to cover these structs with an interface, and the model will call it through the interface. So we'll, for example, I instantiate the layer that implements an interface and we pass it here. Same applies for all of the loss functions and for all of the optimizers. The optimizer has three main functions, but the way I create them and configure, I mean, it doesn't matter. So I think I will start from this. The trickiest part will be actually here. I will need to get back to the original, well, to the implementation and kind of get back a little bit um, to fix them. Because, for example, if I take a look at the, where is it? Mean, where is it? Mean squared error loss, for example, it's built in a way that the predictions has number of the rows equal to the number of the samples, and I assume that it will be only one value. So then I can compare it with the target. But it could be, for example, we can create a regression model that will predict several output values, not just one. And that will be, and the target should be array of arrays, where the row represents the sample and the columns for each row represents the target values. And that won't work, I mean, currently, and the same for the other loss values. So So I will start doing this. I will start from things that are more or less simple. And the first one is the creating interface for the layer and the activation. I didn't work with the interfaces in the Golang, so I need to study it a little bit, and then we can go. For example, I have the layer and the activation, and the all of the things like this one, this, and then dense and the dropout layer. This is what I need to fix. The main thing will be actually the question where I should place an interface. I don't know for now. Maybe actually in the model. What I need to do, this is the models. This is actually the models that I implemented uh, through the book, but I need the model folder. Why? Because I will have the model Go, and this one will represent. Should I put the interfaces here? I don't know. Maybe no. I will put the interfaces for now here. And we'll start. So the first interface, I have no idea what I'm doing. The first interface will be, I would call it layer interface, even if it's spread across the activation and the layer. I mean, even the activation is the type of the, well, logically is, well, it's not the layer per se, but it's a part of the layer. So how it's, I think the layer inter expected declaration found interface. Okay, so let's take a look at the Go. Go interface. The, no, I think I need to go into the guides, most likely. And here, this. An interface type defines a typeset variable of typeset to implement the interface. An interface type is, well, it's in its most basic form, an interface specifies a possibly empty list of the methods. The typeset defined by such interface is a set of types with implement. The name of each explicitly specified method must be unique and not blank. But can I give it a name? Okay, type locker interface. Oh, type layer inter. I'm not good at naming today. If I consider it's an interface, so what we need to do, we have the layer, for example. Let's take a look. For the layer, we should, I don't think we shouldn't have the initialization because it's relevant only for what? For what it's only relevant for layer. Mm, okay. No. I think I don't need the forward name. Okay. Maths. Okay. Layer. Same we have for the backward, right? Layer interface. Form, delete, and this. So this is the interface, right? We for the layer, we have the forward, we have the backward. Then I have a question how we actually implemented. If S1, S, and S2 are also implemented, they implemented the locker interface as well as the file interface. Okay, so then the question, can I, for example, if I go to the model, well, first I will start creating. So I have the type model struct. For now it's empty. I have the model add, and that should be what it should be. What? It should be layer as layer interface, right? Okay, what it means and how I can test it. I can test it in a way that I have model that is model, this one, model.model, and model. Then I need to create, well, for example, I have the layer that is a layer, have activation, which is activation, for example, this one. And the question, can I add it? For example, can't use activation as the model layer interface value in the argument. Does not implement method backward has pointer receiver. Say. Okay, but why it's an issue? Okay. Okay, right now it makes sense. Fix the thing. Working with the interfaces in the Go is a little bit not get used to. Just need some time to get used to this. But it means that I can do this. Also, what I can do, I can I can have the layers, right? And that will be a layer. Can I do this? Right? Layer, layer, append, layer. Can I do this? Well, let's try. No, okay. Let me check. For example, t prints len. I want to print the size of the layer. Actually, it should be s. Mm. Want to? Okay, that works. Nice. But I mean, it actually means that I can, use any, right? Uh, model add layer. I think I drop. I think the problem is with the naming. L A L A drop out layer model adds, yeah, this one. And we do this. Okay. I can use the dropout, or I can use the activation, for example, the sigmoid, right? And it all works. Okay. So I have the model. Well, I can add layers, actually. I have an interface for the layer and activation. Then I need an interface for the loss function, right? How it will look like. Interface, type loss interface. And let's take a look at any loss. For example, this one, I have this, right? And mean, oh, I actually don't need the forwards. I think I need the loss, well, the calculate methods, right? Because, well, I think I will leave it as a requirement. So you should have, even if it's not used explicitly from outside, but it will be a part of the interface. So it means that I can use it. I should create. Well, in order to use it, I should create it, right? So right now we have the loss. We have the loss interface and how it looks like in the function. So we have the model set, which will take the loss and the optimizer. Let's start with the loss. It means we go into the model. Okay, func model set, and we'll have two things. The first one is loss function that is loss interface, right? Then we have the loss function that will be the loss interface, and basically will loss function equals to loss, and that's it. And then we do same for optimizer interface, right? And we'll have the optimizer interface, and guess what? Optimizer interface, and yeah, optimizer. That's it, right? And right now I need to actually add requirements for the optimizer. Let's take a look at we'll have pre-update, update params, and the post update. So we have the pre-update, optimizer interface. We have the pre-update. I have the update params. Update params, and I have the post updates. I'm recording the macros. Okay, delete word, delete, X, and stop. Okay, and then asterisk Q. Okay, and again asterisk. Okay, I actually could do this for. Okay, and we have the optimizer, which means we can do this. Okay, let's try. What we should do, we should have the loss function. For example, binary cross entropy loss. We have the optimizer, which, for example, the optimizer, I don't know, new atom. This one, declare its put news, and then we have model set, and we have the loss function and the optimizer, right? Cannot use all the same, right? Has a pointer receiver. Okay. And this one. So this is the problem that I've been talking before. In an interface, and this is what I will need to fix. In the optimizer interface, I think I declared the target, okay, float 64. And the float 64 I have only for, what was the last one I implemented? The mean absolute error. That should work. Okay. Okay. So I covered everything with That's good. Okay, that works. Okay, let's take a look what they have here. Well, I mean, here it was said that we're going to use unsigned data for the model. So I think that's fine for now that I have the one-dimensional float 64 slice for the loss. I think the main issue will be with the loss, right? Yes, because that's the only one place that has targets, right? Targets, loss, yes. So that's the only issue for the calculation of the loss, because that's the only place where we actually compare the predictions and the results. Okay, this is done. So I have the layers. Where is its model? Actually, I think it will do this. I will just copy them and store. Yes. Start with 56 pointer bytes could be. I mean, what am I supposed to do with this one? I'm no. Okay, I have the. For example, this is the model. We add in one layer, activation, another layer, activation, another layer, another activation, and then we can print the layers. I'm thinking, should I expose it? Probably not. I don't want to expose it, but I want to have model something like print, or maybe no, this description, this that will return string for me. Maybe not. No, let's do this. First, actually interesting how it will look like. For example, if I will print the layers, right? Not sure what it will tell me. I have the loss and I have the optimizer, right? So if I will go here and model this description, what we'll see. It's not cool, right? But what I can do, I can enforce with a layer interface, for example, to have a name, right? Name, return string, same for the loss and for the optimizer, right? And that means that I think for now I should have lots of the errors here because it's not implemented. Okay. What I should do, that should be, for example, func layer, I think name string, and it will return, for example, dense. It's called, how it's called? Layer dense. Okay, layer dense. What just happened? Right? Then, for example, here I will have layer dropout layer name return layer. Okay, drop out That will be the dropout layer. That will be dense layer. Then going forward. Example, I have the, oh, this is the accuracy. I don't need for now. For example, we have the loss, right? Loss, binary cross entropy loss, and it should return name. What it will return? It will return binary cross entropy loss, right? Then I have this one should be no categorical cross entropy loss, and same here, categorical cross entropy loss. Okay, this one is mean absolutes, mean absolute error loss, and mean squared, right? What else I should change? And I should change, what just happened? Why it's not searching? Okay. Can use activation rel. Okay, we have the activations. That's activation, linear activation, and this is linear one, right? Then we have another one is activation rel activation, sigmoid, and softmax. And the only thing is missing is the optimizers. Okay, so we have the new optimizer other. RMS probe, and I will use the short name here, just not to write the stochastic gradient descent as GD, right? Okay, so then the model description should be no for L in, not in, range layers, t print L name, right? Then we print again name and again name. Well, probably it actually should be description rather than the name because I can return some information about this. For example, for the layer, I can return the number of the neurons. For the loss value, no. For the optimizer, I can return some variables. Okay, but I think for now that should be enough. Okay, let's actually not print len. Let's do this. Mm. Mm. Dense layer, relo activation, dropout layer, sigma activation. Okay, makes sense. What is the next thing? So we have the set. Besides, I will create the set. To use the asterisk, that's not important for me. The way I will create an optimizer and loss function is the only thing that here I can pass the number of the neurons and well, I mean, maybe I can ch change it. I'm thinking maybe I can create. The thing is that if I will start creating the struct, then I have a bunch of the variables that are initialized during the thing, and also in the initialization, there are some things happening. I'm not sure how I can create it. I mean, how I can, for example, write it in a single line. Maybe I can do something like this. Why is that? So I can chain these calls. For example, let me try. Example, initialization, I don't know, 10 by 10. Can I take the address? Is it okay? Because in this case, I can write it in a single line. What if I will do this? Okay. But what if I will do this, for example? I have the model, I have add, and have the layer. I do not pass any params, and I call initialization. For example, 10 by 10. Cannot call pointer methods. Why? Maybe I should do this. Cannot call pointer methods on the layer. Okay, maybe I actually do it like this. Drop out layer, and I return the layer itself. We'll see. Ideally, it should take the result from here. So with all of this stuff, but I can actually check, for example, print, I don't know, what is layer weight dimensions. I think that will be the declare but not use. Okay. Okay. Okay, this works. Then I will do it like this. That will be easier to use. Then we will have the train, and this is where the things get more and more interesting, right? Func model train, and what we'll need. Well, I mean, they have X and Y. I don't know. But okay, let's follow this for a while. So we have X, Y, and they will be the dense. Number of the epochs int, and print every, what is the print every? After we have set our model's layer loss function optimizer, the next step is to train. So let the train method for now, we'll make a placeholder and we'll fit soon. I guess how often we should print it, right? Okay, print every, and again, integer, right? For epoch in, I have a misspell, epochs, right? Yes. Okay. For I equal to 0, I less than epochs plus 1, but it's not I. Okay, let's call it epoch. Epoch, epoch plus plus, and to do train. We can then add a call to train the method in the model definition. We'll pass the training data, the number of the epochs, and an indicator of how often print the training summary. We do not need or want to print it every step, so we'll make it configurable. All right. Um, to actually train, we need to perform a forward pass. Performing this forward path in the object is slightly more complicated because we want to do this in a loop over the layers, and we need to know the previous layer's output to pass data properly. One issue with the querying the previous layer is that the first layer doesn't have a previous layer. The first layer that we are defining is the first hidden layer. One option we have then is to create an input layer. This is considered a layer in the neural network, but doesn't have weights and biases associated with it. The input layer only contains the train data, and we'll only use it as previous layer for the first layer during the iteration of the loop. We'll create a new class and call it similarly as the layer dense. We call it layer input. So basically we'll have only the forward path. Then there is a question how I will add it. I mean, because I have this layer interface that requires to have the backward path, and oh, okay, so this is the whole idea. So we're not actually, how it's called, using it to the add, we'll just store it inside. Okay, then it makes, so that will be just a holder for the layers. But there is a tricky part. There is self.layers.pref, and at some point it uses the input layer. So I mean, here it works because the backward method won't be just called on the input, but from the type perspective, that should be, well, there are two options. Either I create something else, or I just ignore the fact that the backward method is empty, and I will create the input layer. I will implement the layer interface, but the backward method will panic because it shouldn't be called. And if I'll make a mistake somewhere, and the backward method is called for the input layer, I will get the panic. I will know that something is not right. And I think I made a lot today. You can see there are so many divs. Um, there is some missing icon in my font, so this is why it doesn't look pretty, but I'm okay with this. And yeah, I did a lot of the things. I will continue with this a little bit later. I still have my to-do, file, to-do, this one, where I need to fix this one, and we will get back to this at some point. I think I will, basically I will need to fix this one, and it will have the implications once I will start implementing the actual training, because right now the train methods, well, the train methods in the model takes y and the target values as the maintenance. And once I will try to use it for the loss function that is implemented as, what is it, float 64 slice, I will have a problem. But I will face it in the next video. Thank you for watching, and I see you tomorrow. Bye bye.